right, so the last problem I'm gonna do is number 11 on your worksheet. Kira's coffee shop makes a blend that is a mixture of two types of coffee. Type A coffee costs Kira $4.25 per pound, and type B coffee costs $5.55 per pound. This month's blend used 4 times as many pounds of type B coffee as type A for a total cost of this amount. How many pounds of type A coffee were used? All right, so when you skim read this problem, you realize it's about coffee being mixed together to make a blend. So this is a type of problem that I call a mixture problem. So this is a really big deal, folks. So let's pay close attention. This is called a mixture problem. It's the first time you've seen this problem in Math 110, and you're going to see a lot more of it moving forward, and they're going to get harder and harder. So mixture problems is when you're mixing two things together. And when you're mixing two things together, you create a blend in a way. So I'm going to draw a picture of what a mixture problem looks like, right? So just because I'm more visual, if it doesn't help you, sorry, do something else, right? So here, if I had, so I mix in something, right? And I'm going to call this the amount of A, some amount of something called A, and I'm going to mix it with the amount of something else called B. So the amount of something called B, and when you mix them together, right, it's just like if I had this water and I poured it in here, and then I had another like drink and I poured it in there and I mix it. What you're doing is you're adding the two amounts together. So what you're doing here is you have amount A plus amount B, right? So here, this shows the total amount. So this here, maybe it's in blue. This is the total amount. Right, and I should have done this in black, sorry. All right, so amount A plus amount B is the total amount. So that's the first thing you need to know. Okay, so the second thing you need to know about mixture amounts is that there's always some type of amount or rate. There's always a rate or percentage attached to each one. So amount of A could be some type of rate. So here in this case, the rate is in terms of dollars per pound. So here I'm going to say sometimes a percentage or sometimes it's a dollar amount. Here I'm just going to call it a percentage, some rate, right? Some rate of A or percentage of A. The amount of B is going to have some percentage or rate of B. And the total amount will also have some type of a percent of the total. So in the second thing you need to know about mixture problems is when you multiply these two together, amount A times the percent of A, you're going to get, in this case, how much it costs for amount A, the total cost for amount A. So this will give you the cost of A. Plus, if you multiply these things together, amount of B times the percent of B will give you the cost of B. The costs, or whatever it is that we're looking at, is equal to, and if I do the total amount multiplied by the percent of the total, you'll get whatever that is in there. So let's look at this problem. So this is what mixture is about, kind of just a brief overview of what mixture is about, and I will explain more of this in class. Okay, so now let's look at this problem. What do we not know? So my tool is this. So it's a mixture problem. This is the tool I need to take out. So that was step one. Step one is to skim read and determine what kind of problem it is. Get the right tool. Step two is to assign a variable to your unknown. So my unknown in this problem then is how many pounds of type A coffee were used. So how many pounds is, what's the amount in A? So I'm going to call this X, right? I'm going to let X equal to the amount of type A coffee used, right? Because that's what they're asking. How many pounds of type A coffee are used? So I don't know what type A coffee is, so I'm going to call it X. So here, I'm going to now start creating this equation. Now I'm going to read the problem slowly and create an equation out of this. Type A coffee costs Kira $4.25. So type A coffee costs $4.25 per pound. So that's a rate. This is the rate of A. Type A coffee, rate of A, coffee, rate of A. So here in this problem, so I'm going to look at this second thing that I wrote here. The amount of A, we don't know the amount. We call that X, right? X is equal to the amount of type A. I have X. Percent of A, or the rate of A. So here is $4.25 per pound. So percent of A is $4.25, 4.25. I put percent here because later on when we get to other word problems, it'll be some type of a percentage and you have to change it to a decimal. In this problem, it's already changed to a decimal for you because it's in dollars and cents. Plus, amount B, what is amount B and what is a percent of B? Well, let's read this. Type B coffee costs $5.50 per pound. So this is the rate of B. Type B coffee costs $5.55 per pound. So the percent of B or the rate of B is $5.55. What is the amount of B then? Let's keep reading. This month's blend used 4 times, ding, 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 used 4 times as many pounds of type B coffee as type A. So type B coffee has 4 times more than type A. So if type A is, the amount of A is called X, what do you think the amount of B is? The amount of B is 4 times as many as A. So here the amount of B is going to be 4 times X. Because X represents the amount of A, is 4 times A. Oops. All right, is equal to, so the total cost then, for a total cost of $1031.55. So they tell us the total cost already. So here represents the total cost. So we don't need a percent of the total or the total. They give us a total cost already. The total cost is $1031.55. So this was the amount, how much it costs to make coffee A. This is the amount that costs for coffee B. And when you mix them together, the total cost is this. So this is your big kahuna equation, the hardest part of the problem. Step 4 is to solve the equation for your variable. All right, so now I'm going to go ahead and solve this. And I actually have worked out the math already. All right, so when I solve this, so notice, first thing you do is you simplify the left and you simplify the right. 4.25 times x, so I'm going to get rid of the parentheses first, plus 4x times 5.55. That will give you 22.2x is equal to 1031.55. So we're doing the math now, solving linear equations. First step is to get rid of the parentheses on the left side, get rid of the parentheses on the right side. Make sure it looks pretty, right? So does this look pretty? Not yet. These are like terms, so you can combine these two. So you can add these two together. You end up getting 26.45x is equal to 1031.55. Now the left side looks pretty and the right side looks pretty. So the next thing we're going to do now is we're going to make sure that the coefficient of x is just 1. So to do that, we make sure that we divide both sides by 26.45. Windy. Divide both sides by 26.45. When you do that, this becomes a 1. So as a result, you end up getting that x is equal to, divide this, you get 39. Okay? Now we answer the question, what the heck is 39? 39 is, let x equal to the amount of type A coffee used. So 39 is the pounds of, 39 pounds of type A coffee that's used in this blended mix. And that's the answer, but let's check it, right? So 39, if we use 39 pounds of coffee, you multiply by $4.25, plus the type B coffee is $5.55, and we use 4 times the amount of 39. So 4 times the amount of 39, so 4 times 39 times 5.55 equals to this. Or the question is, does it equal to each other? So once you do the math of this, you end up getting that this does indeed equal to 1031.55. So the answer does work.